Hello, ladies and gentlemen. I am Dr. Claudia Albers, Planet X research and professional physicist. And today I'd like to bring to you another one of my articles. This one is entitled Settling the Flat versus Spherical Earth Question. Now, in Article 306 entitled Spherical Earth, Measuring the Earth's Radius, I wrote about the fact that the Greeks knew that the Earth was spherical in the 3rd century BC, and that Eratosthenes calculated the Earth's radius over 2,200 years ago. Yet there are many people on Earth right now who believe that the Earth is flat. This state of affairs has been encouraged by the powers that be because they have placed sun simulators in the atmosphere in order to hide the Planet X objects, which are interacting with Earth, and the fact that the sun is dying and turns off periodically due to the presence of these objects as well. And you may look at Article 291 entitled The Sun Disappears, Day Turns into Night for more details. These artificial sources of light give the impression that the sun is inside the Earth's atmosphere by producing divergent light rays, which then give rise to diverging light beams and shadows. But the real sun cannot possibly be in the Earth's atmosphere, because the real sun's light rays are parallel, and because the real sun's distance from Earth was measured in 1769 and is now an established fact. So here is the diagram that I used to detail how Eratosthenes calculated the Earth's radius, and basically used the fact that at a city called Syene, the Earth was directly overhead because it's on the Tropic of Cancer, and the sun's rays are directly overhead or perpendicular to the surface of the Earth at that point at midday on the summer solstice. But Alexandria, which is 800 kilometers away, is no longer on the Tropic of Cancer. It's north of that. So the sun's rays do definitely make a shadow because the sun's rays are parallel and the Earth is spherical. And then from that angle, which is 1/50th, it's the same as this angle, of 360 degrees, and it subtends this arc length. This means that this arc length of 800 kilometers is 1/50th of the whole length of the circle, or the circumference of the circle of the Earth. So from that he could calculate the circumference, and from that we can get the radius. Now, we also know that the sun has to be very far from Earth because the effect of lenses on light was well understood by the end of the 17th century and is given by the lens equation, which was discovered by the astronomer Edmund Halley in 1693. Now, converging lens concentrates the sun's rays at its focal point, and the only way this can occur is if the sun's rays are parallel. Actually, the sun's rays can converge slightly, but only by a maximum angle of 0.5 degrees. This is because the sun is 100 times larger than the Earth. Rays coming from the sun's equator can also diverge slightly, but only by a maximum angle of 0.005 degrees, because the Earth is so much smaller than the sun. But since these angles are so small, we can say that the sun's rays are parallel. So the sun's rays can converge slightly because the sun is so much larger than the Earth, but the maximum angle is 0.53 degrees. And the angle is very small because the distance between the sun and the Earth is, of course, extremely large. So these angles are basically very approximately parallel. And we can get some rays coming, say, from the equator of the sun that do diverge, or diverging when they reach the surface of the Earth, but they can only diverge to by a maximum angle of 0.005 degrees. extremely, extremely small. So basically, we can say that the sun's rays are approximately, it's a very, very close, approximately to parallel. So basically, we end up with parallel rays coming from the sun. And now, if parallel rays are incident on a converging lens, which is a double convex lens, it's a thin double convex lens here, then the lens refracts or bends the light so that it converges at its focal point. And the focal point is characteristic of the lens and the material it's made of, and that focal point occurs at the focal length, which is the distance between the center of the lens and the focal point. And it's specific to each lens. And the sun's rays then, because they are parallel to each other, will converge at the focal point of the lens. So by the end of the 17th century, it could be verified that the sun's rays were parallel by taking a converging lens of a certain focal length and determining that the sun's rays became the most concentrated at the focal point of the lens. Thus, holding a piece of paper at the focal point of the lens for a few minutes would have the effect of the paper catching on fire. And of course, with the incident light coming directly from the sun. This means that the sun's rays are parallel, and therefore the sun is at a distance from the earth, and therefore the only way, that is, it is at a great distance from the earth, and therefore the only way that shadows of different lengths can be created is if the earth is spherical. In addition, the distances that the different planets are from the sun in terms of the earth's distance from the sun was determined by Kepler in 1618, when he used the last of the naked eye astronomers Tycho Brahe's extremely accurate observations of the planets to come up with his third law, now known as Kepler's third law, which gives the relationship between the orbital period and the average orbital radius of a planet. This means that it became possible to determine from the ratio between Venus's and Earth's orbital period that Venus was 72% closer to the Sun than the Earth. Then, using a transit of Venus as proposed by Edmund Halley in 1716, the distance between the Earth and the Sun was determined in 1769, and I detailed that in article 310 entitled Planet X and Simulators and the Distance to the Sun. However, nowadays the distance to Venus can be measured using radar, and from that distance, the distance between the Earth and the Sun can be determined using the relation from Kepler's third law and some trigonometry. So this is what is used. Venus will reach an angle of maximum elongation. And that is basically the furthest angular position attained by Venus from the Sun. So when this is at the maximum size, and that's when Venus is at the point of maximum elongation. After that, Venus starts moving so that this line moves back towards the Sun. Remember, when Venus is over here, opposite to the Earth, then the elongation angle will be 0. When Venus is here, let's go back. So when Venus is here somewhere, this line will be joining there where Venus would be. You can see that the angle now is smaller. So there will be a position where Venus is at the maximum elongation angle. And if we then measure the distance between Earth and Venus, which is here is given by ReV, we can use that distance to calculate this distance. Well, we can calculate either this one or that one, because from a Kepler's third law it doesn't matter. But basically we are interested in this one, the distance between the Earth and the Sun, Re. And the distance between the Sun and Venus is RV. And we have here a right angle triangle. When Venus is at its maximum elongation, we have a 90-degree angle there. So, and this maximum angle of elongation varies between 45 and 47%. So the fact that we have a right angle means that we use some trigonometry. So in other words, cos of this maximum elongation angle is adjacent over hypotenuse, which is RE, so REV over RE. So we can solve for RE, which is REV, the distance that we calculated using radar between the Earth and Venus, divided by cos of the maximum elongation angle, theta E. So from that, we can get the distance between the Earth and the Sun, and we can verify that it is 150 million kilometers or 93 million miles. So in conclusion, since the Sun has been known for over 2,200 years to cast shadows of different sizes at different latitudes on the Earth's surface, and since the Sun is so far from Earth that its rays are parallel, the Earth cannot be flat. The Earth has to be spherical. And here are the references. This is Dr. Claudia Albers, Planet X physicist. Thank you for watching.